Good afternoon, class. As you're completing the homework, I'm going to be giving you a bit of help. I know tonight's homework is quite difficult. So again, good luck as you complete that. Join me on page 49 in your textbook and I can give you a bit of a hint. So start on page 49. And we're just going to talk about the examples 2, 3, and 4. So example 3, again, follow along with me. Example 3 in your textbook, we're starting with number 2. Example 2 in your textbook is about finding the perimeter of a triangle. So the perimeter of a triangle is just the fence around the triangle, right? Here we have something that looks like this. Because F to E is a straight line, all you have to do is count. So from -4 to 4, that is a total of 8 spaces. So we have the bottom length is 8 units. We can count left to right, we can count up and down. But when we're doing the perimeter and we see a diagonal line, such as this line right here and this line right here, we cannot count it simply. We have to use the distance formula. So if you look at step 2 on page 49, you'll see that for length DE, they used the distance formula and the answer was the square root of 45. For EF, they counted and they found the answer was 8. And for FD, they used the distance formula again and got the square root of 61. So when we're finding the perimeter, if it's an up and down side to side line, you count. But if it's a diagonal line, you always have to use the distance formula. Sometimes you're gonna get a nasty answer like this. Sometimes you're gonna get something like the square root of 9, which is 3, or the square root of 25, which is 5. But it's not always that simple. So this is how we find the perimeter of triangles, including perimeter of diagonal lines. You will be doing that on the homework as well. Now let's go ahead and talk about, where's my eraser? I remember using it for this.
Oh, it's on the ground right there.
Okay. So now let's talk about example 3. And example 3 is on page 50, right? For example 3, they find the area of a parallelogram. So here we have a parallelogram like so. The amazing thing about the area of a parallelogram is that the area is base times height. So we find, for the area, multiply base times height. This is the base, and this is the height. So we do not, again, for the area of a parallelogram, the diagonal lines should not scare us. We do base times height. The base of the parallelogram, as we can count, goes from M at -2, -1, to L to -1, right? When we count, that is 4 spaces. The height, we're just counting, goes up 1, 2, 3, 4, 5, 6 boxes. So that means base of 4 times height of 6 is an area of 24 units squared. You might be thinking, Mr. Vera, why is there a diagonal line and it didn't matter? Think of it with me. This is why parallelograms have the base times height. If we were to take a scissor and cut right here, and then take this piece and add it right here, again, we took scissors, we cut this piece out and put it here, what do we have now? A rectangle. Do you see how we can make a parallelogram into a rectangle? The base stays the same, the height stays the same. Okay? Finally, we're going to look at example 4, and then I'll give you a few homework problems to help you on your journey tonight. So, example 4, example 4 is just the perimeter and area of a square. Oh, sorry, that's a wait, is that a square or rectangle? Of a rectangle. Does anyone have questions on how to find the perimeter and area of a rectangle? Going once? Going twice? We're all good with rectangles?
Yeah.
Great, so let's start looking at the homework. I'm going to tackle some very difficult problems. So we're going to start with number 15 of the homework on page 54. We're going to use the diagram to find the perimeter and the area of the polygon, starting with triangle CDE. Looking at triangle CDE, we have a vertex A at -4, 5. We have a vertex B at 0, 3, and then we have the final vertex at F, which is -2, +1. So looking at this, let's go ahead and find the perimeter.
Sir?
Yes?
You messed it up.
Oh, did I?
Yeah.
Oh, I'm starting with number 16? Okay, great. You're right. Thank you. They asked for this too, so go ahead and get that out of the way since I already drew it. So again, this is number 16. I already started drawing ABF. Looking at triangle ABF, are there any lines that go up or down or left to right? Any lines that go up or down, left to right? Or are they all diagonal? So that means we have to use the distance formula 1, 2, 3 times for this problem. Yes. Yes, that's what it means. So I'm going to write the distance formula on the top, and we're going to crank it out. This is the distance formula. Let's go ahead and start with AF. This will be our first point. This will be our second point. So we have x1, y1, x2, y2. Let's go ahead and start with AF. The distance is equal to the square root of x2 is -2 minus -5 squared plus y2 is 1 minus 4 squared. Go ahead and simplify. -2 plus 5 is 3 squared plus 1 minus 4 is 3 squared. We're going to go ahead and simplify a little bit more. That is 9 plus 9. The answer is the square root of 18. So again, the distance is the square root of 18. That is the distance. Let's go ahead and find FB now. The video, you can pause it, and you can just write that for now, okay? FB. This will be our second point. This will be our first point. So we have x1, y1. FB is the square root of x2 is -2 minus 0 squared plus y2, which is 1 minus 3 squared. So FB, 2 minus 0 is still negative 2, plus 1 minus 3 is negative 2 squared. So FB is equal to the square root of 4 plus 4, or 8. And that is the second one. Let's go ahead and use the third one.
AB?
Yep, AB. For this one, we will use this one as the first point, and this one can be the second. We have x2 negative 5 minus 0 squared plus y2 is 4 minus 3 squared. Negative 5 minus 0 is still negative 5 squared, plus 4 minus 3 is 1 squared. So AB is equal to the square root of 25 plus 1. AB is equal to the square root of 26. For this next part, we are going to have to use a calculator to add them up and then get our decimal answer. Okay? So again, we just used the distance formula 3 times in the span of what, 3 to 4 minutes, maybe 5 minutes? Wasn't too difficult.
And that was 16.
Yes, that's number 16. So I'm gonna use my calculator now to find out the answer. I'm not seeing the square root sign on this very weird calculator. So I'm going to ask a student to use their phone calculator and hand it to me. And then the calculator function, I don't need your password? Great. Okay, so if you flip your phone horizontally, give it a second.
I think you have to turn my rotation.
Huh?
You have to flip the rotation. And no. I think it's control center. Flip it.
Flipping?
Yeah, the one. Wait, what did we have the times?
Huh?
What is we multiplying?
I'm gonna ask for Chloe. Is your phone gonna give you?
That's my phone.
Number 2.
Okay.
I have a purple phone. What we have to multiply?
Let's see. We have to, we're not multiplying yet. What is going on?
Sorry, do you want to use this one up there? It's weird.
Sure.
Yeah, I don't know what's going on.
Excellent. So, sorry about that. The square root of 18 is 4.24 units. The square root of 8 is 2.83 units. And the square root of 26 is 5.1 units. We go ahead and add 5.1 plus 2.83 plus 4.24, and we get a total of 12.17 units. That is the perimeter. I need you guys to get comfortable with nasty answers like that aren't cute and cookie cutter, okay?
So we have to do all
Do
of
we have to
that to
write
get
this?
to one answer like that.
Halfway through the answer, because now we find the area. So for the area, it's base times height. This is the height, this is the base, and the area of a triangle is 1/2 base times height. So we would do square root of 8 times the square root of 18 divided by 2, which is the square root of 18, 2.8, 2 times 4.2. The area is 5.98 units squared. And there we have our perimeter and our area.